Okay, here we are, 6-7, day 1. You will have another derivative rule here in a few minutes, and we're going to go through the discovery of it because it uses natural log integration. We are going to discover the rule for taking the derivative of an e raised to a variable power. So we're going to start by letting our equation y equal e to the x. Okay, I see the x up in the exponent. The only way we have to do derivative there is to hit it with a log on both sides, knock it down. So that means natural log of y equals natural log of e to the x. That exponent can now come down as a multiplier. X comes down times natural log of e. Okay, before I jump into derivative, I know natural log of e simplifies to 1. So that leaves the natural log of y equals x. That's a 1 times what you want it. You don't need it there. Now I'm ready for derivative. So it is 1 over y prime. Derivative of x is 1. Now I just have to multiply by the y on both sides to get rid of this 1 over y. So if I multiply by y, these cancel. The derivative equals y, and y is e to the x. So let's see what happened here. I started with e to the x, and the derivative came out, e to the x. Coincidence? No. The derivative of an e to a variable power is itself. Okay, what doesn't show up is if this is something like x squared or x cubed, and that's what we'll put on our green sheet is when that's a u. The u could be anything. So on your blue sheet, we're going to add a derivative, and I didn't put it on here like I did for the natural log, so you could anywhere in this section. I'm going to go right here. The derivative with respect to u of e to some u power. U could be an x squared, it could be a trig function, it could be a quantity to a power, something. The derivative of an e function is itself multiplied by the derivative of the u. So the derivative of e to the u is e to the u times the derivative of the u. Done. Simple. So we're just going to practice this one today. Tomorrow we'll do the integrating, taking it slow. So we've got that, and before we move on, I want to get two properties for you. The two properties right here, because you might not want you'll want to simplify if you run into these before you start trying to do derivative. So let's look at those two properties of natural logs. Let's see what the natural log. So property 1, we've got the natural log of e to the x, and we want to know what that equals. Well, if we just simplify this, I can use the log property to bring this down, and I've got x times the natural log of e, and we already know the natural log of e equals 1, so it's x times 1, or just x. So the natural log of e to the x just equals the exponent. The natural log next to the e cancels out, and you're just left with the exponent. So your first property on your blue sheet, you've got natural log of e to the x. That simplifies to just x. Why is that blurry looking? Okay, property 2. We've got e raised to the natural log of x. Okay, this one's not quite as easy. I don't just get to bring this down. This is not a log down here. I can go through the development of it, but I don't think you care. What's going to happen is the e and the natural log cancel out. This also simplifies to just x. So if I have the natural log of e, that's going to cancel out, leave you with just the exponent. E raised to the natural log again, just the whatever the base was on, not the base, but this part of the natural log. So e to the natural log of x also simplifies to just x. So if you run into these in the problem, simplify first, derivative after. Okay, so we're just going to practice the derivatives and try to pick up on when to apply these properties and simplify first. So find derivative. Example 1. I've got y equals e raised to the 3x. Think of it as e to the u. This whole thing is my u. Derivative of e functions are itself multiplied by the derivative of the u. The derivative of 3x is a 3. And typically we write the number in front, so it's 3 e to the 3x. So it's itself times the derivative of the u. So y equals x to the 5th e to the 2x. Okay, well, what are we doing here? Hopefully at this point you're picking up on, ooh, I've got an x term times another x term. This is a u times a v product rule. So follow the product rule, and when we get to the e term derivative, we'll follow the rule you just figured out. So y prime equals, the derivative of the u is going to be 5x to the 4th e to the 2x plus, keep the first term, derivative of e to the 2x is itself e to the 2x times the derivative of the u, which is a 2. And then we are going to factor these, so see the 2 baskets. And what I can take out of each basket, I've got a 2 and a 5, nothing there. X to the 4th, x to the 5th, e to the 2x. So they both have an e to the 2x, and they both have an x to the 4th. So x to the 4th, e to the 2x. That would leave the 5 plus 4 x's are gone, the e to the 2x. So that would leave the 2 and an x. Done. Number 3, I can fit on these two little lines here. Y equals 5e to the sine x. Okay, there's only one x in this problem. It's right here. So there's no product rule that's going on here. The 5 is just a multiplier that's going to carry along, and then it's an e problem. So the derivative, the multiplier carries along. E to the u, this is my u. Derivative there is itself multiplied by the derivative of the u. Derivative of sine is cosine. So 5e sine x cosine x, done. Number 4, these are nice and short, I can fit it here. F of x equals natural log of e raised to the x squared. Oh, there's that natural log of e. I know that equals, that cancels out. This actually just simplifies to x squared. Do the simplifying first. That's property 1 that I'm using. Cancels. Now I'm ready for derivative. I don't have to worry about an e anymore. It's just 2x to the 1st. Done. So remember to simplify before you do your derivative. Let's see, f of t equals cosine of e to the t. Okay, derivative. Okay, this is a trig function. The angle happens to be an e term, so it's the cosine of u. And inside the u, I've got an e to the u. So it's a trig function first. That's where I start my derivative. So f prime Derivative of cosine is negative sine of the angle times by the derivative of the angle. Well, the angle is e to the t, so the derivative here is itself times by the derivative of the exponent. Derivative of t is a 1. Not that I need the 1 there at all. And just so confusion doesn't happen, we should break this apart and bring this e to the t to the front so we don't think it's part of the angle here. So it's negative e to the t sine of e to the t. We've got, let's see, 2 left. Nope, 3 left. G of x equals quantity 2 plus e to the 3x to the 4th. Derivative. I see an inside to a power. I'm going to follow my power rule. 4 comes down. Inside stays the same to the 1 less power times the derivative of the inside. Derivative of 2 is a 0. Derivative of e to the 3x is e to the 3x times by the derivative of the exponent, which is a 3. Okay, everything's multiplied here. The only plus sign is here. So what I can multiply out in this line, I can multiply the 4 and the 3 and float this e to the 3x to the front and have 12 e to the 3x times this quantity, 2 plus e to the 3x cubed. This one. Y equals 6e to the natural log of 4x. Okay. Before I jump into derivative, I see that e next to the natural log. This is property 2. I'm going to simplify first before I do derivative. All this simplifies to is this 4x. So what I actually have for y is 6 times 4x, which simplifies to 24x. So now when I do derivative of 24x is just 24. So try to catch that. It'll work out in the end. If you miss it, it's just going to be a lot longer. And our last one. This. Y equals e to the 3x. I think it might be the first one I did. There's another notation that they use, and I think this is old school notation before the use of computers and when it was difficult to make exponents. Another thing you're going to see in the book, they'll have this exp. And then in parentheses, 3x. All exp means, I think it stands for exponent, e to the exponent of this. So when they give you a problem like this, exp 3x, rewrite it as e raised to this power. Just write down the problem that way, then you know what it is. It's just a different notation. I believe it's old school. And all it is this right here. So that's all I wanted to point out is you're going to see a couple problems. The author uses it just to see if you know what it is. Just old notation. It just takes you right back to this form here. So y prime would equal e to the 3x times 3. The answer in the back of the book would be 3 for that, exp 3x. I don't care if you use this notation or not. You can. You don't have to. I don't care. I prefer this, but if you're comfortable with that, go with that. Alright, your assignment here. Tomorrow we'll do the antiderivatives, and of course that's always the more challenging of the 2 days. Page 282, quickies 1 through 10, and 1 through 39, odd. Okay, finishes that up.